say so there is this parametric plot which you can do directly. Say 3 cos t. Q. Okay. So whenever something like this will come, you will see that we generally make some typo error, like here parametric. So I think now this should work. Yeah. So this is a figure of an asteroid, which can be easily drawn. And you keep writing in the chat box if you have any difficulty. I will keep noticing. Something called polar plot. These are very, handy when you teach in the class. Say 1 minus cos t. So this is cardioid. If you want them side by side, this P2, you have to give show. Okay, you can control the image by typing image size. I don't know how much is this, but let's see, I think 200. Okay, now it becomes small. Yeah, so this also can be controlled by something called image size. Yeah, I think it should be 150 would be better. Yes. Okay, so now if you want them in the same line, okay, one more thing I like to show. Plot range. So plot range is something which you decide that from x-axis how much range you will take, and from y-axis how much range you will take. Like for here it is from -2. I can make it say from -2 to 1. This is 1. And another one say -1.5 to 1.5. And it should be both in curly bracket, both this is for the x, this is for the y, and overall they should be in curly. So if I do this, now you can see it is from -2 to +1, and from -1.5 to +1.5. So now 200 would have made sense. Yeah. Similarly, if I want it here, the one which you get is automatic. Right now, there is no need. I mean, it is fine, but sometimes you need this plot range. So in this case, if I do this one exactly, you will see the curve is cut because the range is from -3 to +3. So if I put from -4 to +4, and here also from -4 to +4, you will get something like this. Make the image size a bit larger. Now, if you want to plot these two graphs side by side, you write show. If I write P1, P2, that will combine both the graphs. But if I want two separate graphs, you will write show, and then you write graphics row, sorry. Graphics row P1, P2. It should work. Graphics row. No. Okay, I made again a syntax error, as you can see. Show graphics row. So two brackets this side is 1. Should work now. Yeah. So sometimes if you make the syntax error, just have a look. It's mostly the typo. Any questions? No. Okay. Quickly, some colorful plots. Two, three, 4. For combined plot, scale should be matching. Okay, you mean this one? Okay. So by scale should be matching, you mean that, can you just elaborate a bit? Do you mean that this cardioid should be from this side to this side? Do you mean that thing or something else? Yeah, Alok? Acha, the measurement. Still not clear. So what I am doing is I am plotting exactly this in 0 to 2 pi. This is also from 0 to 2 pi. So both parameters are same from 0 to 2 pi. This is a different function. This is a different function. I kept the parameter same from 0 to 2 pi. And then I am combining those two. So if you do that, then you get exactly this figure. By measurement, I couldn't understand what you mean by the measurement actually. If you mean that this should fit inside this, or do you mean this plot range by the measurement? Let me quickly move. Okay. Say we have r theta. If you don't have a theta, you put anything, any variable which you can put by your keyboard. I put this theta so that you can have a feel of polar coordinates. A theta by 7. Okay. So this is in the parameter t, so which is in radian. So I have kept both of the graphs. This is also parameter t, this is also in radian. So by measurement, these two are the same because your parameter is varying from 0 to 2 pi. Here also it is varying from 0 to 2 pi. So I guess this is fine. Okay. Say something like this, and you get a beautiful figure like this. If you want to change the color, you have to give plot style red, and it becomes red. And again, if you want your image size, skip it 200, and it becomes 200. Okay, let's quickly take. So I'm just theta cos theta. Okay, so when you're plotting this, say minus square root of 1 by theta plus square root of 1 by theta, so two graphs can be combined also. And since theta cannot take 0 because it is 1 by theta, so I put a small value here. You could have put smaller values also. It's going to give the same thing. So the purpose of plotting this is 4 graphs, and if I want them side by side in a grid, so the command is graphics grid. And I have to put them you just write pp1 comma pp2 this one, pp3 comma pp4 that is 2. So as you can see, this 2 is one pair, this 2 is one pair, again both of them in a curly bracket. And once it is done, okay, let's see this one. So this is your graphics grid. Now you have got 4 graphs side in a sort of grid, 1, 2, 3, 4 matrix form. If you want to increase and decrease size, you give this image size. So this is 1. So if I write image size, say 200, it becomes a bit smaller. So I make it 400. Yeah, that looks good. And so I can see it in a frame. If you want to put a frame, you just write frame. And if you want throughout, so all, and say I want to color it blue. And you got a frame with color blue. So like that. Any questions? No. Okay. One more thing you need to know, that how to draw a piecewise function. When say fx equal to x when x lies between 1 and 2, equal to 1 minus x squared by 4 when x lies between 2 and 3. So this side of function. Say this is your hx. You have to use the command piecewise. So the first is say minus x. When absolute x mod x is less than 1. And this is in 1. Give a comma. Then you write sin x. When 1 less or equal to. So for less or equal to, if you put a less than function and then press equal to, it will automatically will be like this. Absolute value of x less than, just less than 2. And the final one is cos x if your absolute value is greater or equal to 2. And then you plot say x from -3 to +3. Yeah, and you get something like this. Okay. If you want a different color, I think this is better. Say I make image size 200. I use color function. Which is x. Choose the color to be red. One less than absolute 2. Choose the color to green. Absolute 2. Blue. Let's see what it gives. Okay. Okay. Okay, I guess let's now move to the differential equation. Let me check any questions. No. Okay, fine. So for differential equation, so this is some solution one. You can just write solve one. The command is d solve. Say I take the differential equation as y dash t minus yt minus yt square multiplied by sine t equal to 0. So when you put an equal to, you give double equal to, then you state the dependent variable, which is y, and the independent variable. So this is the syntax. D solve y dash t minus sine t into yt whole square equal to 0. If you just solve it, you get this to be the answer, where your C1 is your arbitrary constant. Just see whether you're getting this output. Okay. Yeah, any question, query? No. Okay, so I hope you got this one. If you want solution. Yeah. So the first one was without the initial condition. So as you can see, it has given the solution with arbitrary constant C1. Then I put some initial condition, y0 equal to 1. The variable, the independent variable is t, the dependent variable was y, and straight away it gave me the solution, sec t. And then I plot, so the command is plot, then evaluate, then this yt. Now from where it will take the yt? So slash dot solution 2. So from solution 2, it will take the yt. And I vary t from 0 to 1, and it gave me the solution. Okay, let's check the chat box. check. If one figure is meter, another is feet, another, yes, you can combine. But in that particular graph, it is not like that because it is dependent on the parameter t, which is in radian, and I have moved that parameter in 0 to 2 pi, both of them. Color function scale small, it is just a syntax which we have to follow to get that output. Okay, any question on the solution of the differential equation? Okay. Then we move to copy this one. So I name it as say S1. So this is the analytical solution of the differential equation, but not always you will be able to get the analytical solution. So obviously I have to go to the numerical solution, and the command for that is ndsolve. So generally we always use this ndsolve. Say I put now y as a function of x, which we are more familiar with, and that is equal to say yx. Make it more complicated. I have a cos, and inside you put x plus again yx. So I guess this looks complicated. Remove the t. I have to give an initial condition. Let's keep it like this. Yx. And now x vary from 0 to 50. Yeah. So I have dy dx is equal to y cos x plus y, and y0 is 1. That's the initial condition. Dependent variable is y, independent variable x, and I vary x from x0 to 50. And I get an output. So they use some method. It can be Runge-Kutta method or any other method, and where they give an output of the function. Now I have to plot it. And for the plot, you have the same command. Plot evaluate. Instead of yt, I will now put yx. Instead of sol2, now the file under which this result has been saved, the name is S1. So this will be S1, and independent variable is X. Here it is 0 to 50. If you want, you can take any number between 0 and 50 to see the solution, and here is the solution. Sometimes if it comes like this, it means that you have to now specify the range. The easy way is plot range, and plot range all. That is, it will be taking. So now you can see that this particular curve has come. If I want to increase it till 50, I get till 50. Okay. So start dot means, say it is just a syntax. It is a calling command kind of thing. So yx, and from where it will take the yx? From here. Now this whole thing has been saved under S1. So that's why this. Otherwise, last time we did, I think, start dot percentage. So if you don't want to name it, but you just want to take the one before this step, you replace this by a percentage. Then S1 won't be there. You have to remove the S1 also. Yeah, any more questions? Okay. Now say, okay, there's one question. Okay, fine. Okay, let's now. So I will be putting a parameter in this. So what I'm doing is, this is an individual problem. I will now insert a parameter A. Anywhere I put it here. And I want to solve this. If I want to solve this, you will see it will give an error. Because now it is says encountered non-numerical value for a derivative and then all this sort of thing. Because the value of A is not defined, it cannot find what is the value of A. If I put A equal to 1, which is exactly the same differential equation, and now it will work and it will give you the solution. Now I've attributed A equal to 1, so I will clear this A. So the idea is first to see that whether this command works. Once it works, then we use that manipulate. So I will first clear A, and then moment I clear A, the color will change, you will see. So this becomes now blue, this is also blue. So no value is attributed to A. And then I will use the word manipulate. So from here to here, the code works. I will just give a comma and I will vary A, say from 0 to 10. And I close it. The moment I do it, I will get something like this. And as you know, I will vary it. And this is how it will be. Okay, let's see the questions. 7. Oh, you should. Yeah, we will solve PDE. Okay, Niladri Ghosh. Okay, you do like this, Niladri. Go to help. Go to this Wolfram documentation. But anyway, I think it should work. So just check whether you have given N, D, solve, all of them capital. N, D, and S, all of them capital. That's the common error we do. Just check that and just report. You are getting ND. So you have written exactly what is written here. Okay. What output you are getting? No output. That Okay, do one thing. Go to this help. Go to Wolfram documentation and type ND solve. And give enter. And it will open something like this. You go down. So I've taken this example. You will see this is there. Just check whether you're getting this or not. Yes, Niladri, did you get it? Yeah. So copy this whole thing and then paste it there, and then you will see there must be some mistake with the syntax. So copy this one and copy this one. And then you will see you are supposed to get this output. Okay, good. Okay. Let's now take two equations. I will first do this one. So I now name this as S2. So I will put two equations here. Say x dash. So x and y are dependent variable and t is the independent variable. So x dash t is equal to R1. R1 xt. Okay, R1, K1, and A are the parameters. The second equation is y dash t is equal to R2 yt minus yt by K2 into A times xt yt. Okay. Now I need two initial condition. So x0, say this is say 60,000. And x0 equal to say 6,000. Then you have two variables, two dependent variables, x comma y, and your t now varies from certain range, say 0 to 1,000. Yeah, non-homogeneous boundary value coming to that. Supposed to give, are you pressing the shift and the enter? Just wait a little. Let me just check. Okay, so I will put R1. Certain values I have to put 0.05 and then put K1. Okay, say R2, 0.8. Then it is K1 to 250, and then it is K2 equal to this. And whenever plot evaluate, so now it is 2 plot evaluate of xt and yt, which will be in this curly bracket from S2, and I will vary my t from 0 to 1000 and say plot range all. Okay, what I didn't do is I didn't put the value of A. Say the value of A equal to 10 to the power minus 8. Okay, now let's activate this one. I put A. This should work. Nope. So I made some mistake. Let me check where. Dissolve xt. So something is wrong with this y. As you can see, it is blue in color, and it should work. So what I'm doing is I'm closing this file. I will save it. I will quit it. Now, here is the file, day 2. Let's see how it works. Nope, so something is wrong here. Check. Okay. Really cannot see any error. Hello. हाँ क्या just hold on a second. हाँ actually I'm in the middle of the lecture. हाँ बोलो बोलो. Some voice cut हो रहा है. अच्छा okay. Okay, let me quickly change this one. Should work where it is. Let me quickly shift to partial and then I come back. Okay. Write PDE1. So the syntax for this is going to be, so for both of them, it is desolve and ndesolve, but there's a way of writing. So I'm first using the desolve, that is you can solve the partial differential equation analytically. So it will be d of okay, the meaning of this is, so y01 and y is a function of x and t. So y01 means this is del y del t. And this is y10. So this will mean 2 times del x, del y, del x. So this is 0, 1. So the meaning is del y del t. And this is 1, 0. So the meaning is del y del x. So basically your equation is del y del t plus 2 times del y del x equal to 0. And you have to solve. So solve 1. Solve PD1 but T. So you are solving this PD, which is under this PD1. Your variable is y, dependent variable, and your independent variable is x and t. And this should solve. Yeah. So it gives you some solution. Then obviously you want to plot this. If you want to plot this, I have to put a initial condition and say the initial condition is simple one. Y0t is sine t, and then I have to take this equation and the condition in a curly bracket, then the dependent variable, and then the independent variable. And this should give me a solution. Nope. I am getting a lot of syntax error. It's fine. Ah. Okay. Let me do like this. Clearing the kernel. Double. Ah, okay. Yeah. Correct. Thank you. Yeah, sometimes we make these silly mistakes and then we look for Something happens. Okay, let's see. Good. Okay, this one looks fine. Then I'm solving this one, which give me the solution. Then I have y0t sine xt, and then I have xt. This should also give me some solution. Yes, now it is okay. And then I have to plot. Plot 3D of y, x, comma, t slash dot for 1, say x from -4 to +4, t from -4 to +4. Yeah. Okay. So few things you need to know now. So as you see, I have changed this file. I opened a new file. So what happens is, क्लास में हो बोलो किसी बोलना है हाँ बाद में okay. So as you can see, I'm using the same kind of, this is cos t, sin t, cos t, and then again here cos theta. So Mathematica is storing this value temporarily in certain memory. And then at one point, this is again sin x. So one point, all the values get jumbled and it cannot actually get, say, the cos t or something like that. In that particular case, it is going to give you some results like this, which I think what is happening here. So it cannot get this value of y because we must have used this y somewhere. So what it is doing is, so in that particular case, what you have to do is you have to just close the whole Mathematica operation and then open it again. So I just change it to different file and now it is giving me this particular, and also I made that mistake of syntax. Yeah, you have to be very careful also. Yeah, any question on this? Okay, let's solve another one. Sorry. 2. Say, so instead of, PD1, I could have directly written the differential equation here. So which is what I'm doing now. Solve d of 2 times yxt comma x plus d of yxt t and say make it a nonlinear by just putting an x and say y0t. So this is with respect to x, 2 times del y del x plus del y del t equal to say sine x. Y0t is cos x and this syntax. And you get some solution. Now we'll use plot 3D. Now it will be solution 2. So it's the same symbol y. I'm plotting this yxt. From where I will get yxt? From here. And it is under SS or S sol 2. So slash dot S sol 2. And say I make it. So it is always safer to make it a symmetric one. So that's why -4 to +4 or -5 to +5. Something like that. And let's see what it gives. Give something. If I want to change it to different colors, I just write color function. Say hue. And it will give something colorful. Okay, questions? Yeah. Okay, nonlinear PD means you have to give an example. For example, give a simple nonlinear PD here. You mean something like using, say, Dirichlet's condition or heat equation, something like that? Okay, heat equation. Let me see. Okay. So let's try heat equation. Okay. Heat equation equal to D of uxt So I'm taking a one-dimension one. Otherwise, it takes a lot of time. This is another way of writing. So it says del u del t equal to del 2u del x square. I could have put some constant here, really doesn't matter. And I take an initial condition. Say exponential of three. So we use another command. I will take the equation, take the initial condition, take dependent variable and the independent variable. This takes a bit of time. Okay. Give some result and the condition for which this result will be valid. And then you plot. Solve 3. X. And I have my t. And I get something. Okay. Let's okay, the codes I can see, you will be able to get this file. There's a book, Mathematica by Example. That's a good book. So this you will be able to, Google it, you will get a free sample of this book. Okay, so wave equation. Okay, wave equation. Let's see. So wave equation is del 2u del t square equal to del 2u del x square. Some constant will be there. Now I need say the initial condition. So I need two initial conditions. One is ux0 is exponential this, and another is del u del t at the point 0 is 1. Now let me solve this. So I make it 4. This is now IC1. This is the wave equation. UXT and this should give me a solution. Okay. Give a solution. Give a solution. And let me plot this. So 4 t is greater or equal to 0. So I will make it 0 now. And I get a solution. Well, Mathematica will be able to solve most non-linear PD, even any numerical solution. Okay, so this is the analytical solution. You can go for numerical solution also. Let me check. Just a minute. Okay. Okay, let me now start this one. I will just give you the package thing. Say parameter estimation. Okay. So you consider this data. Say data one. Say minus 548 minus 435 minus 324 minus 18 0, 3 2, minus 1 6, 15 9, 48 and so on. Then I put, say, L1 equal to what? Data 1. Broad style black. And say point size large. 1, 2. And it should give data. Okay. If I just write how to write metrics with variable entries, that is as functions. Okay. I will just come to that. Oh, sorry, not points, it's plot style. Yeah. Okay, so I have this set of data and I have just plotted them. What I need is that I need a function that will fit this data to a function. Now, as from the data, I had a feeling that it looks like a parabola. So I choose the function. The command is nonlinear model fit. That is your data 1. And it will fit something like A plus BX plus CX square. The parameters are A, B, C. And the variable is X. And once it does that, non-linear model fit. Audio. Can you hear me? हेलो हाँ बोलिए हेलो हाँ बोलिए अब अभी क्लास में हूँ थोड़ी बाद में Yeah, okay. Go on, ask questions. What question you have? Metrics with variable entries. Okay. So metrics with variable entries would be something like this. And you get something like this. Okay, anything else? Yeah, why this is frozen? Anything else? Yeah, can somebody communicate with me? I couldn't understand that what to do now. I mean, should I continue with the estimation of parameters or the audience have more questions?
Dear participants, if you have any questions, you can ask. You can write in chat box, either you can raise your hands.
Okay, one hand raised, but then he or she has to type how to write if we change n cross n matrix for sum of digits of numbers. No, for these things, you have to write small codes. You cannot write a n cross n matrix because then you have to put some value for n. I mean, it's not sort of how to write n cross. If we change n, it will automatically affect on the matrix. So, okay, no. Here you cannot. Okay, I got it. So you means if you put n equal to 3 and then it will give you a 3 cross 3 matrix. Well, for that, there is no inbuilt function, but I mean, you may write a code using Mathematica. Well, there are a lot of limitations of Mathematica. I mean, for example, a simple one would be this one. Just hold on. Well, Mathematica is better because you can do both analytical as well as numerical calculations in Mathematica, whereas MATLAB is mostly for the numerical one. So say this one. Let me take a solution. Say I'm giving a simple differential equation which you will be able to solve by hand, but Mathematica may not. Say y dash x is equal to dy dx dt is equal to yx 1 minus yx k. And then you have x, x. This, if you try to solve by hand, you will be able to. But last time I checked. Okay, Mathematica 13 solves it. But it may happen that in your case, it is not solving it. So can someone quickly check this one, whether it is solving this or not? So last time I checked with Mathematica 12, it was not solving it. So there we will find a lot of limitations. Not that everything can be done with, with Mathematica. Fit. Okay, let me just explain this one. So you have a set of data, which is this one. Then you plot this one. Now you want to find a function that will fit this data. And since this looks like a parabola, I have taken the data. I have taken the equation of the parabola. I don't know what is my ABCs are. And so ABC I need to estimate, and I have this X. And I use the command find fit. So if you use the command find fit, that is again one command. So it quickly solves and gives you the value of A, B, and C. The next step is you have to check that how good is your fit is. So I have my L1. Plot N1 X, and I will vary my X from -5 to say 10. Let's see. Meanwhile, if you have any question, you keep on asking. That way it's easy for me. Okay, I think I have to miss something. By fit. If giving gap command, no, I didn't get you. So you have given a gap between find and fit? Then find fit data one function. Oh, okay, yes. So here this, yes, this B and X, it is taking as one. So there has to be a gap between B and X. Okay. So the syntax is very important here. So let me explain this one more time. So you have this data. I have plot this one. And since I can see that this is a parabolic type kind of thing, I have taken my curve to be a plus bx plus cx square, where a, b, c are the parameters. Now I use the command find fit and use certain method to estimate the parameters, like least square method, mostly it uses it. And then I got this value. Then you can forget this step. Then what I have to do is I have to plot both these points as well as this graph. So that's why I use the command show of L1. L1 is already the plot of these points and the plot of this curve, which it will take from here. When I say from here, that it will take the values of ABCs from here, and then it is plotting from -10 to +10. So you can see it is a perfect fit. Yeah. Let me last try to fix this one. Say this one didn't work. Let's see. It should actually. Meanwhile, you keep on asking me questions if you have any. Okay, okay, I have taken here R1xt xt by k1. K1 has values A has some value x into y dash t double equals R2 yt this x0 some condition, y0 some condition. So as you can see, again, here it's the single equal. So this is sometimes happens, and then the kind of error it will give, you won't be able to understand why it is happening. Now you can see that you can get the graph, and if you plot them, okay, so the same kind plot evaluate. So here it is xt yt is 2, and it should work. No, I made some mistake. So this has to be t. So syntax is very important. If it is not correct, it will not work. Yeah, now it's okay. So it is xt yt, taking the result from S2. Say let's make it 500, and we want to make it 1000, and it's like this. So this is actually something called competition model. So X is one species, Y is another species, and one of them is starting with 6,000, another is 60,000. So this is your 6,000. So at one point it is crossing over, but then it coming to a steady value. And this is the 60,000. It is starting, and then at one point it is crossing over it over time. So till it is sort of 500, your species 1, which has less number of initial condition, was dominating over this species. But then after that, this particular species takes over. So that's how you interpret. Okay, any questions? Any more questions? Yes, Niladri, please. Just type. If anybody has any question, please type in the chat box.
Dear participants, if you have any question, you can write in the chat box, or you can raise your hand, or you can unmute yourself and you can ask question directly to sir.
That would be super. Yeah, Niladri, you can ask if you want.
Niladri Ghosh, you can unmute yourself and you can ask question.
You can ask directly to sir.
Agam sir, kindly give permission to everyone to unmute yourself. Agam sir, आप हमारी बात सुन पा रहे हैं?
हाँ हो गया
Yes. Now Niladri sir, you can ask your question directly to sir by unmuting yourself.
Hello, sir.
Yeah, Niladri, tell.
Sir, yet previous class you have say about your Google Drive link for updated version of Mathematica, or some kind of notes of.
Yeah, so what you do is you send me mail directly, okay? Because it is a not a licensed version.
I get-
Officially, it cannot be done. Okay.
Okay.
So you email me, I will send you mine personally.
Your mail ID can I find from your from the IIT Roorkee or?
I will just give my Gmail.
Okay,
So
okay.
nothing official comes. So in the chat box, if anybody wants a book on this or latest version of Mathematica, you just mail me and I will just send you the link.
So participants, if you have more question, you can ask sir to directly. Okay. So now it is time to conclude for today's session. So thank you everyone. On behalf of Department of Mathematics and entire organizing committee, I feel immense pleasure to take this opportunity to propose vote of thanks for today's session. I express my gratitude and heartfelt thanks to our esteemed guest speaker, Professor Sandeep Banerjee, for giving us your valuable time and sharing your thoughts with us. Thank you so much, sir, for such a wonderful and informative lecture. Sir, you beautifully explored about parametric plot, polar plot, numerical solutions of the differential equations, OD, PD, delay, and stochastics. Its graphical representation using Mathematica and estimation of parameters. Thank you so much, sir, for such a wonderful lecture. My sincere thanks also to the participants for their nice cooperation. I also want to express my sincere thanks to technical coordinator for today's session, Mr. Agam Dwivedi, for his constant technical support. Thank you so much, sir. So now it is time for validatory session. So I request every person please stay here. We'll start very soon validatory session.
Okay, so I'm leaving.
Please don't leave. Thank you so much. Thank you.
Anil, you can continue. Principal sir has joined.
Okay. But sir is not co-host right now. Agam sir, kindly make principal. Sir is not co-host.
बना दिया.
Sir, can we start?
Yes, Anil.
Yes, sir. Thank you, sir. A very good evening to all. I, Anil Kumar Rajak, welcome you all for to the validity session of 1 week online certificate course on computational mathematical software, Mathematica, Maxima and R, organized from 22 to 28 February 2022 by the Department of Mathematics, ARSD College, University of Delhi. The course objective was to provide a comprehensive theoretical and hands-on practical experience on Mathematica, Maxima and R to the beginners. The journey of knowledge started with the motivational words by the Professor Gyantosh Kumar Jha, Principal, ARSD College, University of Delhi. In this journey, we got the opportunity to listen the great academician like Professor G.S. Tuteja, Professor in the Department of Mathematics, Zakir Hussain, Delhi College, University of Delhi, Professor Sandeep Banerjee, Professor, Department of Mathematics, IIT Roorkee, Dr. Ashok Kumar, Assistant Professor in the Department of Statistics, University of Lucknow, who in their discussion explored over all aspects of computational mathematical software, Mathematica, Maxima, and R. They highlighted in details of course contents like understanding conjectures using Maxima programming, introduction to Mathematica, basic arithmetic operations, 2D and 3D graphics, vectors, matrices, limit, integration, and differentiation. Numerical methods and its applications using Mathematica, numerical solutions of the differential equation, OD, PD, delay, stochastic, etc. And its graphical representation also. And also its application in mathematical modeling using Mathematica. Estimation of parameters, introduction to the R environment, working with R, objects in R, data import and export, variable handling in R, summary of basic statistics, descriptive statistics and visualizations, measures of central tendency, measures of dispersion, skewness and cortices, and graphics in R, etc. The enthusiasm and the liveliness of the participants made the course a great success and narrates that the course has accomplished its objective. There were 160 participants, registered participants in this course, in which there were 60 faculty, 49 research scholars, 33 PG students, and 20 UG students. I take this opportunity to welcome the principal of our college, Professor Gyantosh Kumar Jha, sir. And first of all, I would like to thank our honorable principal, sir, for his constant support, guidance, and encouragement. Now I invite our principal, sir, to share his thoughts with us, sir.
Thank you, Anil. The course convener and coordinator of mathematics department, Mr. Rajkumar Bhagat. Another coordinator for this program, Dr. Anil Kumar Rajak, colleagues and my dear students. Other participants, of course, other guest participants who are present in this valedictory session. I would like to congratulate our colleagues, especially from mathematics department, who have organized this 1 week online certificate course on computational mathematical software, Mathematica, Maxima, and R. I think that every participant have learned about these software, which are very useful for the benefit of students, for the higher study, for their better learning. And I'm glad to know that there were participants, teachers, participants, researchers, students, and I think they have 169 or 160 registered participants for this certificate course. Apart from classroom teaching, apart from courses, these kind of workshops, seminars, certificate courses provides an opportunity to the student to learn more about the subject. Whatever I have gathered from you people regarding mathematics and regarding these softwares, I think that Mathematica, Maxima, and R, these softwares are introduced by Delhi University in course curriculum recently, since some years ago, and they are very useful for the advanced study of mathematics. So it's a good efforts, and I hope that every participant have learned and they have enriched themselves by attending this certificate program. Once again, I congratulate Mr. Rajkumar Bhagat, Mr. Anil Kumar Rajak, and other organizers for organizing these certificate programs. Thank you so much. Thank you.
Thank you so much, sir, for your encouraging and motivational words. Now, I would like to invite our TIC and course convener of this course, Mr. Rajkumar Bhagat, sir, to say a few words. Rajkumar, sir.
Good evening, everyone. My heartiest thanks to all the participants who patiently attended all 6 sessions of this certificate course on computational mathematics, mathematical software. I know it is difficult to cover every aspect about Maxima, Mathematica, and R software in 12 hours. Really, 6 days is not enough to cover these 3 software. But we have tried to cover every important aspect so that you can start and work with these software. Sometimes breaking momentum is important. So we try to gather momentum. Breaking inertia and gather momentum is very important things. And with these 12 hours, where during this 12 hour, you all got brief introduction and brief idea about these 3 softwares. So certainly this is going to break the inertia and gather momentum to learn some new things. So the important thing is, hopefully this 12-hour session increased your curiosity and eagerness to use these 3 software in your domain area. Any domain where you are working, whether you are a professional or whether you are research scholar or teacher or undergraduate or postgraduate students, in any domain where you are working, we hope that these 3 softwares is going to help you. You know that R is very powerful and multifunctional software. Why I am emphasizing on R with respect to Maxima and Mathematica, because these days, as I mentioned, we are living in very entirely new world. And in this new world, data analysis is very important thing. And this R software, that's why this R software is very important, and certainly it will help you in any domain, whether you are when you are working with as a data analyst or working as a social scientist. So this R software is going to help you. So one thing that I want to emphasize, these days many new career opportunities are emerging and waiting for you in the new emerging area of data science, data mining, deep learning, machine learning, and so on. So all these areas are based on data and data analysis. And if you are looking forward to make a career in this area, so our software is definitely going to help you. So my best wishes to all of you. I hope this course will help you in career advancement and your growth. Thank you. Thank you very much.
Thank you, sir, for your nice words. It is my privilege to have been asked to propose vote of thanks on this occasion. I, Anil Kumar Rajak, on behalf of Department of Mathematics and entire organizing committee, take this golden opportunity to extend a heartiest vote of thanks to all the dignitaries attending this validatory session of 1-week online certificate course on computational mathematical software, Mathematica, Maxima, and R, organized by the Department of Mathematics, ARSD College, University of Delhi, from 22 to 28 February 2022. I would like to express my sincere thanks to our Honorable Principal Sir, Professor Gyantosh Kumar Jha, for his constant guidance, his mentorship, and for continuous encouragement. My sincere thanks to our TIC and course convener, Mr. Rajkumar Bhagat sir, for taking initiative to organize such course for the benefit of faculty, research scholars, UG and PG students. My sincere thanks to our entire team comprising of course coordinator Dr. Preeti Jain, organizing secretary Ms. Silpi Jain, Dr. Priyanka Yadav, Mr. Chhatrapal, Mr. Agam Dwivedi, and Mr. Kapil Kumar. Technical committee, Mr. Amit Kumar, Mr. Astos Meena, Mr. Anand Tiwari, Mr. Rajpal Rajbhar, and Mr. Vinit Raj. Organizing committee, Mr. A.S. Prajapati, Dr. Monica Suri, Professor V.K. Tyagi sir, Ms. Jyoti Kaushik, Dr. Pratibha Mehrotra, and Dr. Amit Mittal. We are really thankful to our entire organizing team. Now I want to thank the participants for joining us in making this course memorable for everyone. So thank you everyone. So now there is some announcement for participants. So dear participants, I request to all of you to fill feedback form and of each day and quiz assignments given to you. This is actually mandatory for students of e-certificate. We shall email the e-certificate within 10 days to your registered email ID. We shall also send an email you all a Google form for e-certificate today. Kindly fill that necessary particulars correctly because we are going to use that particulars for e-certificate. So whatever necessary thing will be, we will email to all the participants. So kindly see that email and fill the required things. So thanks everyone again. Thank you participants. Thank you our organizing team. Thank you our technical teams. Thank you everyone. Agam sir, in कर दीजिए.